By the way, I should mention I'm going to be out of town next week, so this class will not meet next week. And the lab, I'm only going to have it open on Monday. I will not have it open on Wednesday. The Wednesday class will meet um, online only, and the Thursday and Saturday class I've canceled for next week because I'll be at Worldwide Hacking Fest or Wild West Hacking Fest in Deadwood, Arizona. Anyway, so uh, and therefore the Friday workshop will not happen next week, but it'll resume the week after. So, all right. Anyway, today we're at CNIT 152, and we're down to network evidence here. So let's take a look at that. This is, of course, one common type of evidence. You capture network traffic. So once you have it, then it's a very good place to go to get information about an incident. Most incidents involve communicating with an external command and control server, and it's a pretty easy way to identify infected machines. Also, you have to do it to look at the scope of a compromise to see how many machines are involved. It's another good clue. So there's types of network monitoring. There's four basic types: events, packet captures, sessions, and high-level statistics. And these are closely related to how people monitor networks for non-security purposes, like to bill you for like long-distance charges and stuff. So event-based alerts, you run an event detector, which is an intrusion detection system that recognizes malicious activity on the network, like Snort and Suricata. So it has to have a list of rules defining what a malicious activity is, and then it sends you some kind of notification when a bad thing happens. Full packet captures are the kind we're used to using Wireshark, where you capture all the network traffic, and therefore you can reconstruct entire files that are transmitted and such. This is, of course, the most complete information, but it kind of resembles a whole disk capture. It's usually far more than you need, and it's kind of big and a lot of work to interact with. Session information is much simpler. You just record connections and addresses. There was a connection from this address to that address at this time, and it went on this long. And you might just have a summary number like how many total bytes were transmitted or something, but you don't have the full information to reconstruct what was sent. This is the kind of thing that people refer to as net flow. This is, I think it's, yeah. Well, this is similar, but NetFlow, I think, is what you have here. That was Cisco's proprietary product used to monitor traffic, so you could do things like limit the total bandwidth allowed to each user and bill them for their usage on a shared line and things like that. And high-level statistics, or any other kind of statistics where you turn on something like Bro, now called Zeek, which can just monitor traffic and say how many DNS requests are there, how many FTP requests are there, how big were they, general statistical information like that. So, the most common one, of course, and the easiest one to use is event-based, just like antivirus. Your intrusion detection system just notices suspicious things and alerts you about them. So it has signatures or indicators. It might be as simple as just IP address and port. If that's all that has to do, that's very easy for the sensor to do. But of course, that's probably not enough information to detect a malicious activity. A more complex indicator would be looking for string patterns in the data, and that can easily cost the sensor so much CPU time that it doesn't process all the packets. Especially this is notoriously easy to do with Snort, because Snort relies on regular expressions, and regular expressions are very difficult to write, and they are sort of recursive, so it is pretty easy to write a regular expression, which takes a lot of CPU to evaluate. So here's a Snort rule that will detect brute force attacks. It's looking for TCP going from the external network at any address to the home network on port 22. So any traffic coming into port 22, here's the message it's going to send if it detects it. And here's the... If it counts 5 attempts within 60 seconds, then it will log this event, saying somebody is trying to connect from the same address 5 times to port 22. Within 60 seconds, that's some kind of attack. That's a reasonable activity. This is an easy one. All right, so you put this in the Snort configuration file. This is the simplest way, is that it will just put it in a file. All right, here's one that will detect a fake SSL certificate. There was a known fake AOL SSL certificate being used, and so you could look for this exact signature. It's just a hexadecimal signature. Look for that pattern of bytes. this will only appear in that file, and then you'll be known somebody's trying to use that fake SSL certificate. So that's another way to do it. All right, so then you can do header and full packet logging. If you really want to record all of this, then you might want to, because you're looking for something that is not detected by your known rule sets, which is very commonly the case. I mean, that would be too easy. If you're known to, if your IDS went off, then it's easy. But that means it's an old attack that's already known. Usually you have a new attack, which is not in the IDS, and then you're going to have to just log all the traffic in some way to look for it. So you collect some evidence, and you can determine whether to treat packet captures as evidence and generate a train of custody. You might have to do that if you're planning to go to court. Most companies are not. They just want to stop the problem. They really don't care about going to court. Usually it doesn't benefit your company in any way to go try to hunt down the offender and hurt them. They're probably in a foreign country. Who cares? You just want to stop it. But anyway, all right. So your IDS can retain the full session, but for targeted collection, you use a real wire packet capturer. TCP dump is best. Wireshark is not really good for continuous packet capture. It's not safe enough and it's not efficient enough. TCP dump is better. So TCP dump is what you should use. It can do a complete packet capture. Now you can limit the capture to 64 bytes, and then it will only get the headers, but it will not get the contents of the packet. So you'll know the source address and the destination address and the time, but you won't know all the contents. This is to get a summary. That's what they call trap and trace by law enforcement. This is like a pen register capture of a telephone wiretap, where all they get is this phone number called this phone number at this time, and that's all they get. They don't get the actual audio. That's one way to do it. All right, you can do statistical monitoring. That's what NetFlow does. Number of packets in each flow. This address sent that address, this many packets at this time. And like I said, the main purpose of that was so you could charge your customers for the total bandwidth they were using in a shared line. And then there are commercial visualization products that will give you graphs of these things to monitor the network traffic in various ways. Flow Tools and Argus are more, they'll take PCAPs, turn them into something called Argus format, and then let you have nice pretty graphs like this showing the bits per second, and here's some kind of spike in traffic you might want to investigate. And here's more information on a log scale, your various traffic patterns. And so you can see this is like 10 or 100 times more than usual. And here's the usual behavior. This is the sort of thing you get from things like the open security onion can make graphs like this of network traffic when you get it working. It's pretty hard to use, although it's probably better now than it used to be. I tried to teach a class on it maybe 8 years ago, and it was in an early version and very unreliable. People tell me it's gotten better. Anyway, the main replacement we use is Splunk. Splunk is much nicer. But it's expensive. But people pay for Splunk because it really works. You know, if you're a small nonprofit or something, then you use free stuff because you have to. But if you actually make any money, then you spend money on good tools because the time spent by your humans is important. And you want to save them effort by buying them better tools. All the large companies do that. All right. It was the same with hardware. I mean, you get them good computers because the hardware is very cheap compared to the cost of your staff. So making them use an old computer that doesn't work well is not cost effective. But in small businesses and nonprofit, you're usually volunteers and donated stuff, and you just try to live with whatever you've got. All right, what kind of monitoring gives you the ability to reconstruct complete files? The full packets give you that ability. By the way, it's a whole lot harder than it used to be because usually the traffic is encrypted. And so even with full packets, you're going to somehow need to get the decryption key. Anyway, all right. All right, what kind of monitoring is NetFlow? It's high-level statistics. It just gives you a summary of a complete flow. This server connected to this client and sent this many this many bytes or this many packets. All right. All right, what does Snort do? It does event-based. It detects bad things on the wire. By the way, I thought it was kind of funny in lore. When Snort first came out like 20 years ago, the security people said, oh, good, this will be the end of security. This will solve all our problems. We've thought that many times, you know. Some new feature comes out, and of course, it never is that great. But it was, you know, useful to find bad things on the wire before they get to your machine. That would seem really helpful. And it's part of your security platform, but it certainly doesn't solve all your problems. All right, and what does TCP dump perform? Yeah, it can do full packets. It can also do just headers. All right. All right. Oh, there they are. Good. All right. Good. All right. So, setting up your network monitoring. The simplest way, of course, is just get a network tap. For slow networks, people used to just use hubs. Now you typically buy a special device, and so you have a network tap that you put in line where every bit of traffic that goes through has an extra copy of it sent out a different port, and you can plug something up there to monitor it. You can use a server or a laptop running something like TCP dump or Snort on it. All right. And this is what you do if you're setting up like an ad hoc monitoring after a network, after an incident is detected. Now, IDS platforms cannot do both network surveillance and intrusion detection at the same time. And if you set an IDS to capture full content, that will burden it, and it will be less accurate at detecting attacks. That's the problem. Line speed is getting very fast, and it's hard to process all the packets at line speed. You can't really do a lot of processing on them and keep up with the line speed. All right. So you define your goals, make sure you have the legal right to do what you're doing. Stick in your hardware and software and secure it, because your IDS system will be a target of attack. And make sure you captured the data somewhere where you're going to be able to detect the data you need. Now, one common issue is you sniff the internet connection, and you do not therefore know about local connection between your servers and clients on your local network. And that might be where bad things are happening you'd like to know. So it's difficult to collect and store every packet on a high-speed link. What's recommended is to get a rack-mounted server here. Linux distribution. Linux is now considered best at this. Until recently, it was FreeBSD that was considered the best as a platform for network monitoring, but now Linux is better with some new kernel features. So before an incident, if you plan ahead, then you install some kind of commercial network monitoring. This is a very good idea. I remember years ago I heard a guy say that if you have network packet captures, this lowers the cost of instant response by something like a factor of 10. Now I have actual evidence to work from instead of trying to reconstruct things from imperfect logs. Anyway, so Cisco has a bunch of systems available, and a lot of companies make commercial network monitoring systems. And I mentioned Security Onion. This is the free Linux distribution to do this. It reproduces some of the features of Splunk. Like most free Linux-based products, it's hard to set up and hard to use, but you save all the money for commercial software. All right. So you figure out where are the egress points, where the traffic leaves your network. Find out if you use specific routes to control traffic. You probably do want choke points. If you don't have some point where all the traffic has to flow through, then you don't know where to put your firewall rules and other security features. So you usually do route all the traffic to pass through one area. And then consider how it's encapsulated. You might be using VLAN trunking. You might be using various levels of like GRE. There's various ways to encapsulate packets. And if there are network address translation devices in use, which there usually are, and proxy servers, then you have to be aware of that, because then you don't really have access to the real addresses of the endpoints in the traffic, and that's going to limit its value unless you also record that information. That's the problem. If your network was as simple as like one laptop and one internet connection, it would be easy, but your corporate network is much more complicated, and its traffic is kind of a mess. And when you change the network, that might improve things, like you ensure all company locations go through a single location with multi-protocol label switching. This is what ISPs do. They mix all kinds of traffic through one device, labeling it and encapsulating it. That's one way to make all the traffic pass through one point. Put your sensor in a locked room, of course, to maintain chain of custody. If you're ever planning to go to court, you're going to have to testify that we made sure that nobody was manipulating the sensing device. Keep it up to date, document everything, check the integrity of your operating system on the sensor, and test how well it works. Can it keep up with your line speed? Are the signatures good enough? Check your signatures to make sure that they trigger correctly and don't have too many false positives, and you should have performance metrics to tell you when it starts dropping packets. All right, so network data analysis, once you've got it, this is what Wireshark is for. Wireshark is not intended for live capture of significant quantities of data. It's not fast enough. It's not designed to write to the disk. It writes to RAM, so after a while it just fills up RAM and crashes. And it's not secure enough, because every packet is passed through a bunch of analyzers, protocol analyzers, thousands of them that are just contributed by the community, and many of them are not very secure. So you can actually take over a machine through Wireshark if you're sniffing live traffic. So you're not supposed to be using it for detecting live traffic. You use it for analyzing captures that you got with TCP dump. And then it's excellent. That's why all the graphical features and all the protocol handlers are there to help you go through it. Now, looking through large packet captures, hunting for something new is very difficult. Using targeted queries in Wireshark and limiting your scope is a good way to do it. And we'll do this in the projects. NetWitness Investigator is another product people like. This automatically breaks the traffic up into categories, automatically extracts file transfers and images and things like that. All right, then you can get the logs from your network devices. Oh, and let me get the Twitch chat up here. Okay, nothing new. Just wanted to have it visible. All right, so your routers, firewalls, servers, and all the other devices have logs. Your DHCP servers have logs. Your firewalls have logs. So that's the thing. You should have logging on these devices, and of course pass them to a central log monitoring system like Splunk. Your IDS sensors may capture things. Your host-based sensors may detect the result of an attack, and your system log files may show useful information, which is why instead of having these logs all over the place, you really have to have them in one central place like Splunk, so you can search through all the logs for the various clues of what's happening on your network. All right. Now, another thing is if the attackers try to clean up their tracks, then they might delete the logs on the end devices, but they're probably not likely to be able to delete the logs on the firewalls and elsewhere. And that's why, one trick people used to do, I don't know if they still do it, is they would connect a sniffer at layer 2 only. So the sniffer did not even have an IP address. It would just copy every packet at layer 2, and therefore you can't even detect it. So even if you think you've found all the devices and cleared all the logs, there's another device recording everything that does not have an IP address, just making a copy at layer 2, almost impossible to detect or stop. That's another thing you might do. All right, and like I say, log aggregation, as I pointed out, is important. Your logs come from all different systems. They're in all different formats, and that's what the Splunk does. It tries to help you sort through that mess, which is very much like sorting through the internet, where you have just a whole bunch of data that is not really structured all the same. All right, let's try another Kahoot. All right. All right. All right. Which one can do intrusion detection or surveillance, but not both at once? That's the idea. All right. All right. Which one uses custom Lua decoders? That's Wireshark. Lua is the language they write those packet dissectors in. And like I say, it's not safe because all those decoders are not really put through a security review. All right. All right. Which one will make sure that your operating system files remain intact? That's what Tripwire does. Tripwire is a product's been around for decades that just calculates the MD5 hash of every system file and records it, and it alerts you if anything changes. So you know if anybody's messing with your operating system. A defense that I think should be included in all routers and switches and firewalls, but it's not. All right, how about a top-rated commercial IDPS? Cisco's the only commercial product up there, and I haven't worked with it. This may be an out-of-date result. I don't know if Cisco has a new one, but this is one of theirs, their intrusion detection and prevention system. All right, good. Good. All right. So, let me stop this recording.